Comiendo. Hola, hola. Vamos a bajar la música. When I put my top, I lose my cool. I don't look at you, say why. Feeling inside, so we stop me. Por mientras como, por mientras como, un videito de YouTube. Eh, no, un videito de YouTube a gusto. Ay, va a ser a lo barrido. Va a ser a lo barrido. A ver, podemos ver. A ver.
So what is
Mientras,
ClickUp? ClickUp is an
mientras como.
all-in-one productivity software where you can manage everything and anything related to your work. Your documents, your chats, your whiteboards, your projects. The value of this, you don't have to buy
Una Flying Wing se hizo.
How's it going, guys? Max here. I know it's been quite a while since I posted the last video on the channel, so I'm back with something pretty exciting in particular. Join me today and we'll make an RC fixed-wing aircraft like none other. A remote-controlled Arduino-based 3-channel flying wing. And the bottom line question is, will it fly? Let's find out. So let's make this thing. Let's start out by making the hot wire foam cutting tool that we'll use to shape the plane. For the tool, I'm using 1/4 mm nichrome wire, which can be found in soldering irons or hair dryers. So we will basically take a rigid bow-shaped type of wooden frame and tightly wrap nichrome wire to each end. Let's solder and connect up electrical wire to each of the ends, and in the meantime give the tool a momentary push button. Hope you enjoyed my little performance there. So a thing I noticed with the tool is how it sags when it's heated up due to the wire expanding. Well, a little thing to counter that effect would be simply a retraction spring. So we'll hook it up here as a part of the wire that heats up. So as the hot wire heats up and stretches out, the retraction spring compresses, keeping the tension on the wire as you're cutting. So that makes this hot wire tool complete. Moving on, let's take a quick look at the materials and parts we'll need for this plane. So the core material to this wing will be this 1.5 inch thick styrofoam board that I have over here. And yes, this is just your everyday cheap styrofoam that's made up of these little balls that fall apart and crumb all over the place, making a big mess. Well, that'll be a mess no more with this styrofoam cutter that we just made back here. So let's hit it, shall we? So to achieve the desired size and shape of our swept back wing, we're going to follow this design over here. The wing will have a wingspan of about 80 centimeters. So to start with the slicing, let's cut this sheet of foam in half, dividing it into what will be 2 wing halves. Then we'll cut off the excess around what was marked. With our wing halves prepared, let's make the 2 airfoil shaped stencils, which will go on the sides of each half wing section and be the guidelines to help create that correct airfoil shape so that the plane can gain lift. We may also sand the edges a bit so that the hot wire smoothly glides over them. Aside from wood, a dense and smooth material such as acrylic may be used to make the stencils as well. So let's stick these two stencils onto the sides of one half wing section
Estoy
and add
comiendo.
some toothpicks to the front and back so that you're guaranteed with an accurate leading and trailing edge. Setting the power supply to 9 volts, and yes, you may instead choose to use 9-volt batteries for this. Holding down on the hot wire tool's push button will slowly but surely make our way from the leading to the trailing edge, making sure the wire enters and exits the sides at the same time. These ones came out looking pretty rough. It's not as easy as you may think. It took me about a couple of attempts before I started getting smooth looking wing half sections. Now that we're starting to achieve much better results making these half wing sections, we can already see where this is heading.
Le di al cero por accidente. ¡No! Ah, qué verga. El arroz integral está bien bueno.
Now we will adjoin the two wing half sections with these 4mm wooden dowels. This solution will work great as the wing's reinforcement. I recommend having them as close as possible to the center of gravity of the final plane. The more we reinforce the plane, the better, as long as we're keeping the weight down.
Mm-hmm.
Let's also reinforce each end of the plane with some barbecue skewers. With the foam wing being all reinforced, we can start making the needed cutouts. Except we won't yet touch the area where the electronics will be sitting in. Out of the same piece of foam, we'll cut out each of the elevons, the only two control surfaces which the plane uses to pitch and steer with. These are technically the combination of the ailerons and elevons seen on a typical plane. Now we'll start by laminating them and then the rest of the wing. Sellotape seems to do the job pretty well. It's thin, lightweight, and even sticks to the foam nicely. My best advice for laminating a wing with tape is to start from the trailing edge and all the way up to the leading edge. We'll stick the elevons to the wing body with a strip of tape from the top, and then a few smaller pieces from
Oh, la bestia, qué fuerte está esta Jamaica.
Since sellotape has heat shrinking properties,
Como cuando está bien fuerte y te pega
use
de...
a hair dryer to smoothen out any rough areas where the lamination went a little wrong. While we're still taping, let's add some decorative strips of Kapton tape. Right, so the flying foam wing itself is now finished. It's been reinforced with wooden sticks, laminated with tape. It's turned out to be pretty sturdy, and it already looks quite sporty. Yeah, so now on with the electronics, starting by making the receiver unit. Before we mount any modules or components onto the PCB, we must first add in some female pin headers so that the modules can easily be replaced if needed. This board will feature an Arduino Nano microcontroller board and NRF24 radio frequency transceiver module. To give the radio frequency module a stable supply of power, we'll give it this 3.3 volt regulator down here. To smoothen out any ripples and power to the radio transceiver, we'll give the inputs and outputs of the regulator some filtering capacitors. With all being mounted onto the perforated board, we can start with the wiring. For the best power filtering to the module, it's actually better to solder them as close to the pins as possible. To keep the weight down, we can also trim off excess perforated board. The receiver has ended up weighing 16 grams. For the servo motors to connect to the receiver, we'll solder on some extended pin headers. For the battery of the plane, we'll form 4 of these lithium polymer cells into one battery pack. Two pairs of cells in series and then put together in parallel will equate to a 7.4 volt 500 milliamp hour LiPo battery pack. This battery pack set of connectors will be shortened down to something a lot more discreet.
Así es como logré controlar mi mundo usando Adobe Premiere Pro. Primero realicé 2 tomas, una de mí mismo realizando la...
Yo sigo con depresión.
With the current system to see that the circuit is working. The Arduino codes for the transmitter and receiver can be found linked in the description. Here we'll measure and cut out areas on the plane where the servo motors will be embedded into. Let's be sure to embed them into the thicker part of the wing, closer to the leading edge. And the servo wires going all the way up to the receiver can be embedded in the wing too.
Cochino. Está.
Why don't we also give the battery a sturdy wooden floor and a Velcro strap to keep it down tight. Since the circuit is powered by the right, folks? At this point, I'm almost convinced the powertrain just isn't enough for this type of plane, and it clearly has a lack of thrust with this cheap drone propeller. But I got another thing up my sleeve, so I ordered in these 5-inch plane propellers, which are actually pretty rigid, unlike the drone propellers which would flex out at high RPM. With a new plane propeller that's got the right shape, I have no doubt it'll at least give a bit more thrust. But whether it's enough thrust for the plane to produce lift, that's another question. Okay, I admit it, the plane for sure is too heavy with this brushed motor. So brushless it is. I ended up ordering in this tiny 7000 kV Emax brushless mini quad motor, purchased along with a 30 amp 2S and 3S brushless ESC. This motor, with a no load RPM of up to 60,000, this thing will rip. We'll also stick to the same propeller as before. So hooking up the rest of the circuit to this new brushless system, let's just check to see that everything will work. Without wasting any more time, let's get right into swapping the brushed motor for the brushless one. To get the little guy mounted, we're first going to need to make a little mounting plate. It's as easy as raising the using a better way to achieve those. Wait, let's test her out. It took a number of consecutive failed attempts of me trying to get it into the air. It would simply smack down into the ground, but as I started getting the hang of launching it, it really took off. From coming in over the wing, the center of gravity as we're building the center. So now the vicious plane motor won't start up all of a sudden, slicing up the pilot without his input. Now the joystick will stay down at 0 throttle without holding on to it. By the way, you may check out my previous video where I showed how to make the transmitter.
How to get the most of Grammarly free.
It's Kayla on behalf of Grammarly to tell you.
Ay.
So this is her maiden flight. Let's see how she goes. Alright, it started well, but kind of veered off to the side and crashed. Not a single scuff. She survived that. Let's keep rocking.
Muy bien, niño. Gracias.